Along the Pacific coast, everything seemed ordinary. But deep beneath these waters, immense pressure had been building for years. Far below, the Nazca Plate strained against South America. At 8:42 a.m., the locked fault finally gave way. A subtle rise rippled across the Pacific, unnoticed by those above, yet it carried unimaginable force. In seconds, the ocean rose higher than the skyline, an unstoppable wall of nature's energy. Beneath Chile, two colossal plates constantly collide, the Nazca and the South American. When the fault locks, stress builds silently. Every second adds to the energy waiting to break free. At the moment of rupture, the seabed lifts by several meters, displacing billions of tons of water above it. Water is incompressible. When the seafloor rises, that energy must travel, forming a wave that races outward.
Traveling at over 700 kilometers per hour, the wave crosses entire oceans with barely a ripple seen from above.
As waves reach shallow water, they slow down, but the energy remains. The result, the wave now spans hundreds of kilometers. Its energy invisible, its arrival inevitable.
Now, the ocean's fury races toward land, a chain reaction shaped by Earth itself. The Nazca Plate dives beneath South America, compressing the crust until the fault snaps, releasing centuries of stored energy. Every movement adds friction, microscopic shifts accumulating invisible tension beneath the sea. From a single point on the Pacific floor, energy ripples through the planet, felt thousands of kilometers away.
The sudden uplift of the seabed displaces an immense column of water. Gravity pulls it back. Deep trenches allow energy to travel further. Shallow shelves amplify it. Chile has faced the ocean's power before. In 1960, the largest earthquake, each step in magnitude releases about 30 times more energy than the one before. A 9.5 quake releases power beyond imagination.
The 2025 Chile earthquake ruptured a 400-kilometer stretch of the Nazca subduction zone near Concepcion. The rupture extended 35 kilometers deep, releasing energy equivalent to 10,000 nuclear detonations. Parts of the coast lifted by over a meter, while others sank, reshaping bays and channels instantly. Each ripple represents unimaginable force, spreading outward across the Pacific basin. Within hours, sensors in Japan and Hawaii recorded signals from Chile's ocean floor.
Though distance softens intensity, confined bays and inlets can amplify returning waves.
While tectonic quakes move the seafloor, volcanic eruptions push water through explosive collapse. A large meteor strike can displace more water in seconds than most earthquakes in history.
Though vastly different in origin, all share one law. Energy must move. The same forces that carve Chile's peaks also shape its ocean. Beauty born from pressure.
At microscopic scales, mineral grains shear, melt, and slip, transforming pressure into motion.
Today, Chile's network of sensors and satellites tracks every tremor, turning chaos into data.
The wave height is exceeding the 9-meter mark here.
Rerunning the coastal impact simulation now. We need to issue the highest alert level for Sector Gamma.
Modern modeling allows scientists to watch the ocean move, frame by frame, force by force. Thousands of equations simulate how depth, slope, and coastline shape each incoming wave. Automated warnings ripple through the Pacific, buying coastal towns precious minutes.
From Chile to Japan, sensors speak the same language, turning nature's chaos into human understanding.
To decode today, we look back at signals the ocean left behind. When the sea pulls far from shore, it's not a gift, it's a warning. A long, lifting surge, faster and taller than intuition suggests.
If water withdraws suddenly, move inland and uphill immediately.
Far offshore, tsunami waves are long and low, carrying energy, not drama. When period and height align, barriers can be surpassed. Geometry can magnify motion, turning a swell into a surge.
Training plus alerts turns minutes into safety.
Slip wasn't uniform. Clusters of motion shaped wave patterns. Depth, slope, and shape steer incoming energy. Different sources, similar sequence: origin, withdrawal, surge, and resonance.
Sensors captured long-period signals hours before landfall elsewhere.
Gauge by gauge, the ocean told the same story. Water recedes. First surge arrives. Oscillations follow. More than one wave is common.
Preparedness is a system. Signals, routes, practice, and trust.
So, what if a great rupture struck the Pacific today? Let's model it. Imagine a magnitude 9.5 rupture beneath Chile's coast, an event equal to the largest in recorded history. Billions of tons of water are lifted. Gravity responds, sending energy outward in every direction. A wall of water 100 meters high curves across the Pacific, its crest stretching beyond sight. Within 15 minutes, energy reaches Juan Fernandez Islands. Within 12 hours, Hawaii and Japan. Major ports face waves exceeding 20 meters, yet every harbor's response differs by shape. Reflected waves converge again, striking coasts hours later. The ocean's echo. We have a critical alert in the Pacific sector. Reroute Satellite 7 immediately and confirm data integrity. Next up, what if Antarctica's ice collapsed into the ocean? The next simulation begins soon. When the sea calms, we're left not with fear, Seven, but with understanding of the forces that shape our world. Every grain, every drop speaks the same language of physics. The dialogue between gravity and motion.
Nature doesn't punish, it reminds. Every motion beneath the sea writes a lesson above it. Every movement beneath the waves carries a message, not of fear, but of knowledge.